This is the muscle fiber that contains long cylinders inside of it called the myofibrils. This is where calcium travels through. And then this right here is the thin filament, also known as the actin. The actin contains long lines on them called the tropomyosin. And on the tropomyosin is troponin that locks it into place. And then right under it is the thick filament, also known as the myosin. On the myosin is a myosin head, which binds to ATP, which then separates into ADP and phosphate. And right here is what represents the body where ATP travels through.
Neurons stimulate a muscle to release calcium ions into the myofibril. This will then have the calcium ions bind to the troponin, which creates an opening that allows the myosin head to bind to the actin. This will then send ATP to the myosin head as it detaches from the actin filament, which will then go into a resting state. The next step is hydrolysis, where the ATP splits into ADP and phosphate, and then the head will lift up from the resting state. After hydrolysis is the third step, which is the cross bridge, where the myosin head then attaches to the actin. As the transition to step 4, the power stroke, the myosin head will also lose ADP and phosphate during step 3. Last, step 4, the power stroke allows the muscle to contract as the myosin head pulls the actin. This process will continue to repeat until the motor neuron stops sending acetylcholine.
Being cardboard, our project has many limitations. The first of this is the inability to have the project bond to the troponin. Since we use beads, we cannot show the transfer and change of the shape. Instead, we have the calcium deposit into the box. We cannot have the myosin head actually attach and detach from the thin filament. Furthermore, we did not show the signal, as it would make the project much more complicated. Despite these limitations, we feel as though this project is as close to an accurate representation of the sliding filament theory. If we were to do this again, we would add a place within the troponin for the calcium to deposit, and we would improve the cog mechanism to ensure ease of use.